My name is Cosmin. I work as application security engineer for Axway, and I do a little bit of security research in my little spare time. It's my first time as a speaker at DefCamp, and I have to say that I'm nervous as hell. Today, I'm going to tell you a story. But before we start, how many of you are driving a Honda? 2, 3? I bet you're more than that. But anyways, have you ever tried to hack your Honda? All right. Cool. I have good news and bad news. The good news is that after this presentation, you will be able to hack your Honda, really. It's no joke. The bad news is that I have 46 slides, so you will probably get bored. All right, so, yeah. As I said, you will be able to hack your Honda, but not thanks to me, but thanks to the guy who published this site. I don't know if you can see it. It's autohack.org. Root your Honda head unit and install apps freely. As you probably imagine, I drive a Honda. I'm very proud of it, Honda Civic 2018. I found this site, and I was so really excited. Of course, the first thing I did, I clicked on Civic 10th generation. That led me to this instruction page. Connect your head unit to internet with Wi-Fi, etc. Launch the browser, navigate to that. I was so excited, I didn't even read the rest of the instructions. I just clicked the first link, open it in a new tab in my laptop's browser, of course. I wasn't even in a car. What I got was this very nice screen saying, get start. Not get started. Get start. My car is black, by the way. So I was still in my laptop's browser, not in my car. With all that, of course, I clicked on get start. Please enter the authorization code. And I was like, it's been a while since the last time I've seen a JavaScript pop-up asking for an authorization code. And I was like, what are the chances this guy is doing client-side validation? Something is wrong here. So I've checked the source code of the page. My assumption was partially true. He's not doing full code validation, but he's doing kind of validation, so key length different than 10. And I was like, what are the chances those characters to be only digits? We'll see. So at this moment, my only goal was to put my hands on the APK file that I thought it stored somewhere on the server, right? So I could bypass this authorization code and get the application link. I thought I will go to my car, navigate from the browser to the application link, and it will install. Boom, so easy. It wasn't that easy. So what I did, I just started one of my favorite tools, Derb, the short version of Derbuster. Probably you are familiar with it. It's it's command line, and provides great results, even with the default word list. And I've tried to highlight here the first 3 results that caught my eye, /profile, /test, /download. Can you guess which one I've tried first? Easy guess. I wasn't so lucky with the download. /profile instead was more generous. I got this nice login form. Of course, what I did, I tried the classic combinations, admin, password 1, 2, 3, with no luck. But I had even something better. And I'll make a few steps. Register. I was like, there's no way this register link to be functional. But it was. I created an account with a random generated email address, which provided me with a limited account, though. So I still didn't have access to what I was interested in. resources were unavailable. I was kind of disappointed. This is not me, by the way, but there's not much difference. The third result, the test page, gave me hope because on the bottom of the page, I found this link. And I was like, got you. I found you. But actually, it was a no. Because that link was dead, I got this disappointing message, the page cannot be found. But then I thought maybe that link is outdated. Maybe he deployed a new version and he forgot to update the link. So I was like, let's brute force the link. So I pulled out my burp proxy, trying to brute force the version number. This is how I configured the attack. I used the cluster bomb to replace all the possible combinations with numbers from 0 to 100. I wasn't successful though. I was still getting 301 HTTP response with the same message page cannot be found. But then I remember about the derb tool that I left it running in the background. And boom. And I was like, are you kidding me? I was trying to brute force the link, and it was actually /app/latest. Of course, I put it in the browser, and boom. I've got the download window. So I got the APK, and I was like, woohoo. Of course, next thing I did, I run to my car, open the browser in my car, navigate to that link, hoping that it will install the app. Of course, it didn't work, so I realized I have no way of installing it without rooting the device. So in a way or another, I had to find that authorization code. So I went back to the starting point. The authorization code. Remember, we established that the code is 10 characters long, so there's a big chance it contains only digits, right? So there we go, chapter 2, brute forcing the authorization code with the almighty app spider. Oh gosh, you really cannot read this, right? Here's the request that the app was sending to the server when I was clicking the get start button. And what it's sending here, it's the key. So what I did, I configured the attack to replace the key with every possible combination from 10000 to 999 and hit start attack. Shortly, I had some good news. First, the server had no rate limiting mechanism or any other kind of defense mechanism that could, I don't know, stop me to perform the brute force attack. And second, I had always the same response length. Even the HTTP status I got was 200. I have the same, always the same response length. So it was a big chance that in case a valid code is found, the length would be different. So my assumption was actually right. You can see the results here. I got the first valid code on the first row like in 84 seconds. And the second one, I got it after another like 2.5 hours. So at this stage, I had already 2 validation codes. This thing doesn't work anymore. I had 2 valid codes there under the payload column, you can see them. Cool. Okay, after manually validating those codes in the browser, I went to the car, opened the browser, navigated to that link. This time I had the code, I entered the code, and you can see on the right-hand side my Civic Dash with the app, Honda Hack app installed and running. On the left-hand side, it's me being so happy about doing it. But the story doesn't end here, because the features I was actually interested in required the pro version. For the pro version, I need a key, and I didn't have a key. So at this stage, I must confess, I was more intrigued and curious about how this guy managed to implement a anti-cracking technique or something rather than actually using the app. And there you go, going pro. So what I did, I set up an environment with the tools I thought I might need for reverse engineering a Android application. And this is kind of the steps I followed, starting with a static analysis of the app after, of course, after unpacking and decompiling it. Looking through the code, and there's a reason I highlighted strings here, because strings, as dummy as it seems, it's still a great way to find what you need when looking into a code that is not yours. Followed by a dynamic analysis of the application, running it, trying to know how it behaves, and most important, capturing the traffic, because pay attention, it was clear text. So HTTP, pure, I was like, what? We're in the 80s? So yeah, without a HTTPS, I was able to put myself in the middle, intercept the traffic, and yeah, doing a whole bunch of stuff. And finally, after identifying in the code, the piece of code that was doing the code validation actually, the key validation, I was able to extract that code, just put it into another application, and running it separately, thus obtaining actually the key that was matching against the value that the user was entering in the UI. You'll see that in a moment. So static analysis revealed some interesting piece of stuff in the beginning, like this hard-coded path there, / etc. out code, and I was like, I bet the code is stored here, and when the user enters it in from the UI, it's matched against this code. So I was in a hurry, opened a shell to the AVD, the Android virtual device. I navigated to that path, but guess what? It wasn't there. So I've created it and put it a dummy value there. And I was like, I put this dummy value here, I go in the UI, I enter the same value, and that's it. Wrong. Wasn't that easy. So, as I said earlier, I start digging after strings. This is the pop-up asking for the key, right? So I search for upgrade to pro version. In the folder that I got after unpacking the application, without being an Android expert, really, I shortly noticed that each string that it's displayed in the UI, it's mapped to a label in some XML file. In turn, that label has an ID. Of course, I searched for this ID in the source code, and I found nothing. And it took me a while to figure out that while this ID is in hex notation here, the decompiled code that I got from the Java decompiler were in decimal, so I had to convert them, obviously. Okay, so searching this time for the decimal notation of the string, I found another piece of interesting code. We can see the setTitle method here, called with our interesting string ideas parameter, which totally makes sense, right? You want to set title of that string, and a couple of other string IDs here and there that, using the same searching methodology, I've identified them as being open Bluetooth, registration key error, and upgrade to pro succeeded. So all those things assured me that I'm looking at the right piece of code. And more than that, because of registration key error here, I knew that this m.a method here is the method who does the code validation, the key validation. This is how m.a method looks like. Pretty ugly, right? This is the same method in a more readable form. We can see it does some processing on the two parameters, and here on line 11, it does compare the results of the two results of this computation here, whatever that is. But still, we didn't know anything about those two parameters, where those came from. Where are those? So let's see where else the same method is called. There it is. And it's even more interesting than the previous call. So looks like the app is crafting a URL. It's making a HTTP request to that URL. And later, the HTTP response is decoded as a JSON. And the app is looking for error and key JSON fields, passing, I don't know, can you guys see this? I'm really sorry. So this is another call to m.a method, passing a context object and the string key received from the server as parameters. Now let's see how this communication between the app and the server look like. Because remember, it's plain text. Capturing the traffic between the app and the server was really easy, because when running in the AVD is basically routing all the traffic through your main host network interface. So all I had to do is to start Wireshark and start monitoring. Here we can see what the app actually does. What the app actually does. So it does a request to activate that PHP, sending the key, that surprise is the key that we've entered in that file, along with an ID. And of course the key was wrong, so what we got was error, failed to activate Pro. This message error, it's shown, it's displayed in UI. So this kind of validates what we saw in source code, right? Okay, so let's take a closer look at the most interesting piece of code, right? The m.a method, the routine that validates the key. And I'll need you to focus a little bit here. So this is the m.a method. After making a null check against param string, the second parameter, which is the key, right? And it does another check. It calls method age, passing that context object. The method age is in the right-hand side here in the top corner. The method age, it's calling another method b, and the result is compared to a hard-coded string, which is like 2, 4, 6, 8 characters long string. So we know what the result of b looks like, right? And it's even more interesting because b is called here again at the next line. And the method b looks like this. It's a one-line method returning a hex notation of a hash code of some string contained by prefix dash something. And this something is here. This something actually checks for the presence of a Bluetooth adapter. If it is, it returns the get address. If it's not, it should return null. And this is interesting. This is a coding mistake, because the guy who wrote that assumed that if no Bluetooth adapter exists, it will return null, and it's using that there where you can see it highlighted in red. It's using that check, and for me it looks like a anti-debugging technique. The thing is that because of the type of the result of this method here, which is string, Java will automatically cast the null object to null string. So actually, that check there, that condition will always be false. Okay, so simplified, our str variable from here, it's a hex of a hash of prefix plus Bluetooth address, which is null, and if you compute that, you get that string. But you know what? I think I saw this before. Right, it's a device ID. Now, going further in the validation routine, the device ID is appended to another something, which is really, this is the method, another A method. It really returns google.com, lack of inspiration. The result is then hash code again, and the hash code is stored into the integer I. That being said, at this stage, this is the same code validation routine, simplified. At this stage, we have control over all the parameters engaged in this validation. So I is google.com plus the ID that we know. J is derived from I. And then here does some computation, some bit shifting on I and J. And it's comparing to the first half, and this is interesting again, to the first half of key from server. See, array of strings of 0 after splitting it by, where are you? There, third line. So it only validates the first half, I don't know why. So what we actually need to find out is the result of this computation. And this Java code does exactly this. It takes device ID from the command line argument, it does the super ultra secret complicated computation, and returns the result. If you take this code, compile and run it, you get a 4 characters code, which is basically the first half of the key. You can find this code on my public GitHub profile. Sorry about that. So we have the first half. The next half could be really any random 4-character string. It is not validated in any way. What I did, just type that into the application, hit OK, and finally I was happy till the end. Upgrade to Pro succeeded. All right. As a summary, because what we want to do is we want to learn something from this story, right? I'm not here just to show off. Let's see hows and whys was this possible. Remember, all started with a client-side validation, right? Don't do that. Don't do client-side validation of any secrets. You can validate like phone numbers, I don't know, email addresses. Don't do any kind of validation on the secrets. Why on this earth would you restrict the password pool by allowing only digits? It makes no sense. This is what in defense security we call weak password policy. He did that. The absence of a web application firewall or any kind of rate limiting mechanism, either at application level or network level, allowed me to brute force that authorization code. Remember, I got the first code in 84 seconds. If you publish a service, be aware, put a firewall in front. Next one, the clear text communication between the app and the server allowed me to intercept the traffic, reverse engineer the communication, and even impersonate the server. I've modified the DNS table in the AVD, and the app was sending the request to my web server under my control, and I was sending funny error messages like howdy or hey, how's it going today? And they were displayed in the application. Next one, a weak code obfuscation along with hard-coded strings allowed me, by only taking a very quick look at the code, I was able to have an idea at least about what that piece of code is doing. So try to not hard-code anything. thing in your app, not paths, not file names, especially not passwords. And last but not least, no anti-debugging mechanisms. Remember the wrong assumption that if there's no Bluetooth adapter, that condition should have returned true so that the application won't run. In the AVD, there is no Bluetooth adapter, but because of that assumption, I was able to run and debug the app in the AVD with no problems. This is no magic. You know, when you're an individual and you publish a service like this, you do these mistakes. Maybe the overcome is not so bad, but if you're a company, you don't want to do these mistakes in your products or services. In Axway, we try to keep a close look on those rules and many others, of course, and make sure we don't do this kind of mistakes. This is all I had for you guys. I hope you're not asleep. I'm open for questions now.
Saw you. I saw you.
Hey, you still have the app on?
Yes, I do. I have to upgrade it.
So you still have the traffic ongoing on HTTP? So I can hack your car again?
Yeah.
Did you change anything? No.
No.
So
Do you know what my car is?
I will find. I know your name, so I will find something about you on the web.
Yeah, and you know it's black.
Yeah, and I know it's black, so I have some ideas about your car. Did you think about changing something to this? Because you already find the fact that the traffic is on the HTTP and is not encrypted. Do you think to change something on that?
Honestly, I didn't, but that's a good point. Maybe I should.
Okay, thank you.
Thank you.
So
we have here someone. Okay.
yeah, so we have and then we'll move next.
Cool.
Hello.
Hey.
So my question is, what was the end result? What were you able to do to your car after hacking it?
So the last generation of Civic has a really annoying feature. Every time you turn on the engine, you got a pop-up warning in the dash saying, hey, drive safely, etc. And you have to click OK on that every time you start a car. So I was able, using this app, to just deactivate that feature. So it's more easy.
Okay, but anything like harmful or?
Like what, sorry?
Harmful, like damaging your car or-
there are a bunch of other features. First one is installing any APK. Without this app, you wouldn't be able to install. I installed Waze, but it was way slower because it's still a low-budget Android tablet at the base, and the Android version is old. It has some other features, like you can remap the buttons on the wheel. You can remap them to do any other functions than just playing the next song or turn on the volume. But I didn't use it.
Okay, thank you.
Thank you.
So Cosmin, it was a question there.
Yeah, I saw someone there, and there are a couple of other folks here.
I see. Yeah, saw you. Okay, yeah, you will be the next.
You showed us your method of doing. Okay, sorry. You showed us your method of obtaining this app and the pro versions, but I'm wondering, what is the legit or regular way of obtaining it?
The regular way is to send that guy $18 and he will send via PayPal, and he will send you the code. This is how his marketing campaign looks like. I don't know if it's real. Didn't try it. I have better ways.
We have another one here.
My turn, right? Yeah, exactly. Yeah, my question was like, did you try some function hooking, FreeDA style? Was it possible? If yes, no, why? Could you explain us a little bit? That would be cool. Thanks.
I didn't try it honestly. Of course, it's you can do way more things than that. And I'm not an Android guy. I'm not even a I don't know mobile device pen tester or something. So I didn't go that far, but it would be interesting.
Thanks. Nice presentation, man.
Thanks.
Okay, Cosmin, two more. It's okay? Or
Yeah,
one?
I'm fine.
Yeah, you're fine?
Yeah.
Okay, so let's pick up someone from the first row.
Don't pick this guy,
This.
please.
Here. Where?
Don't pick. Don't
Okay,
pick
I
him.
will not.
I'm just kidding.
Okay, so let's pick you.
Could this be, thank you for the presentation.
You're very welcome.
Could this application be dangerous? I mean, like, could someone comes around your car, hack your application and accelerates your car without your permission, you crash and you die?
No, no. So I didn't spotted any backdoors or something that could allow someone to hack you by having this application running. I didn't spot it. I didn't target that kind of information specifically, but don't trust me. I mean, don't install it and say that guy at DefCamp says I'm safe. So,
Okay, thank
Yeah.
you.
mhm.
Okay, we have another more. Bear with me, only...
Where are
Sorry.
you?
Here you go.
I don't see you.
I'm here.
Okay.
So we have... Where is that gent? Who was it? Who was it? You were... Okay.
It's too far,
Here.
Rizwan. It's too far.
Oh, okay.
You can ask me after.
I'm here, I'm here.
Hi. Isn't hacking an application that is not yours and you don't have permission to hack slightly illegal?
Did you guys paid him to ask that question? It is, but DefCamp allowed me to present that, and I think we're okay, right?
Hey, I have a short question. Can you now mirror your phone based on the fact that you have this feature? So this app? Can you do that?
I could do that. I could do that before because I have that
Okay.
Android Apple CarPlay thing.